So let me share the conventions. Conventions for using Lenz law. In books, the given method not applicable in all cases. In few selected cases, they're applicable. So let's go for a very generalized one. So what is the first convention? Is if the flux is into the flux, if it is directed into the plane. Okay, let me take the. There's a loop, and if magnetic field is directed into the plane, then the flux linking the loop is taken to be negative. I'm saying it's a convention. What is that green color? Green color is a loop. Huh? Any shape you can take it. If the B bar is directed out of the plane. The flux linking the loop is said to be positive. Second convention, if positive flux increases, d phi by dt will be positive. I think this is quite clear. You go back to kinematics, dx bar by dt. If x bar increases, definitely v bar should be positive. No, it will be along positive axis. The similar idea. If positive flux decreases, d phi by dt will be negative. Third one, if negative flux increases, positive flux increases, d phi by dt negative. Positive flux decreases, d phi by dt negative. Negative flux increases, d phi by dt will be negative. Negative flux decreases. And the fourth one, EMF induced is minus of d phi by dt, or I is equal to minus of d phi by dt by resistance of the loop. Substitute d phi by dt sign. Substitute with sign. This is a basic definition. Next, again, what is saying is, the fifth one, what is saying is, if I or EE comes, if I is positive, means calculate if you end up I positive, then the induced current will flow in a anti-clockwise. There's a loop. There's a loop. So that induced current, what happens? If it is a positive, it must flow anti-clockwise. So high is what you should call induced current, a very specific name. So what is high? As E is induced EMF. Induced EMF. This is called like a induced current. If I is positive, anti-clockwise. If I is negative, then it should be clockwise. EMF also you can put sign. Sir, where is EMF? Again, you have to replace with the battery symbol. I'm just showing with only the current. It will be much easier for you. So if I is positive, then current in loop flows in counterclockwise. If I is negative, current in loop flows clockwise. Just by seeing several numericals, they have generalized. Okay, there's one basic structure of how to use Lenz law, means how to predict direction of induced current, not making any guess. Systematically, we have to apply these particular things. So let me give examples so that'll be easy for you. All our numericals, if you know direction of current, then you'll be in a better position. Why we are giving so much of importance, you can see it. Once let's learn how to use that one. So let me take the same example. So there's a track. Let this be a resistor R. I'll give velocity to the rod.